In this video, we are going to cover 9.4 chemical properties. At the end of this lesson, students should be able to explain the identification test for aldehyde and ketone using 2,4-dinitrophenylhydrazine, which is the Brady's test, Tholen's, Fehling's, Benedict's, and Schiff's reagent, and differentiate between carbonyl and other compounds, aldehydes and ketones using the above tests. We can see here there are 4 main tests: Brady's test, Tholen's test, Schiff test, Fehling's or Benedict test. First, we look at Brady's test. If Brady's test is positive, yellow precipitate is formed, which means the compound has carbon double bond to oxygen. If this test is negative, there is no yellow precipitate formed, which means this compound has no carbon double bond to oxygen. This test is used to differentiate carbonyl compounds which has carbon double bond to oxygen with another compounds that has no carbonyl group. Let's look at the equation for Brady's test. The Brady's reagent is 2,4-dinitrophenylhydrazine. If a carbonyl compound reacts with 2,4-dinitrophenylhydrazine, the oxygen from the carbonyl compounds and 2 hydrogen from 2,4-dinitrophenylhydrazine is eliminated as water. The product is now carbon that is double bonded to the nitrogen of 2,4-dinitrophenylhydrazine. This compound is the compound that gives yellow precipitate. But if the reaction is negative, there is no need to draw the product of the reaction. We must also write the observation for the positive and negative tests. For positive, we will write yellow precipitate form, while for negative tests, we will write no yellow precipitate form. The second test is Tholen's test. If Tholen's test is positive, we will see silver mirror or precipitate form as shown in the picture. The compound is an aldehyde. But if the Tholen's test is negative, there is no silver mirror or precipitate form. The compound is most probably a ketone, only if the chemical formula is the same as an aldehyde. So, this test is used to differentiate between an aldehyde and a ketone. If we see the equation for Tholen test, if it is a positive test, which means there is an aldehyde, the Tholen's reagents are silver ammonium and OH-. The product we will write as carbon double bond O, and the hydrogen is replaced with O- plus silver with an arrow pointing downwards to represent the silver precipitate. Look at the second equation. The same goes for the second equation. If it is positive with the Tholen's test, we will write the product as C double bond O and the hydrogen is replaced with O minus plus Ag with an arrow pointing downwards. The observation for tolerance test, if it is positive, is silver mirror or precipitate form. If it is negative, we do not have to write the product and we will write the observation as no silver mirror or precipitate form. The third one is Fehling test. If Fehling test is positive, brick red precipitate will form, indicating the compound is an aliphatic aldehyde. But if the test is negative, there is no brick red precipitate form and the compound is either an aromatic aldehyde or a ketone. We can see the example of brick red precipitate form as shown in the picture. This test is used to differentiate between an aliphatic aldehyde and aromatic aldehyde or a ketone. Please note that Fehling's test and Benedict's test produce similar results. If we look at the equation for Fehling test, the region for Fehling's test is Cu2 plus and OH minus. If we have an aliphatic aldehyde react with Fehling's region, we will get positive results, which means there is brick red precipitate form. The product, we just draw carbon double bond oxygen. The hydrogen is replaced with O minus plus Cu2O solid, which means it is the one that gives the brick red precipitate, plus 3H2O. The observation for a positive Fehling's test is brick red precipitate form. If the test is negative, we do not have to draw the product of the test, but we should write the observation as no brick red precipitate form. The last one is Schiff test. If Schiff test is positive, pinkish purple solution is formed as shown in the picture. This means this compound is that the compound is an aldehyde. A negative Schiff test means that there is no pinkish purple solution formed. This means that the compound is most probably a ketone if the chemical formula is the same as an aldehyde. This test is used to differentiate between an aldehyde and a ketone. For this test, there is no need to know the equation for the test. The following table shows the summary of the identification tests. There are 4 tests: Brady's, Tholen's, Fehling's, and Schiff. Brady's test is used to differentiate between carbonyl compounds and other compounds. The region is 2,4-dinitrophenylhydrazine. If there is a carbonyl compound, it will be a positive test. The observation is yellow precipitate form. For Tholen's test and Schiff's test, it is used They are used to differentiate between aldehydes and ketones. The regions for tolerance test is AgNH32 plus and OH minus. If there is aldehyde, the observation will be positive, which is silver mirror or precipitate form. While for Schiff's test, if there is an aldehyde, the observation will be positive, which is pinkish purple solution form. And lastly, Felling's test is used to differentiate between aliphatic aldehydes and aromatic aldehydes or ketones. The regions are 2Cu2 plus 5OH minus. If there is aliphatic aldehyde, the observation will be positive, which is brick red precipitate form. If you are given two compounds to differentiate, for example, a butanol and a butanol, one is carbonyl compound, one is alcohol. So you can use Brady's test. There is 3 points you should remember to write. The first one is the name of the test, which is Brady's test. The second one is the equation. You must write the equation for butanol and 2,4-dinitrophenylhydrazine, including the products, but for butanol, you don't have to write the products, only the regions. The third one you must write is the observation. For butanol, the observation will be yellow precipitate form, while for butanol, the observation will be no yellow precipitate form. So remember 3 things to write when you want to differentiate between two compounds. Use the right test, write the right equation, and write the right observation. That's all for this video. Thank you.